Okay, so this is the second part of our tutorial about Gauss's method. Okay, for the continuity of the lecture, let me just write down. Okay, we are in examples, and we have just done the first example of the tutorial. Okay, in this second example, we are going to say it's basically the same thing, but we are being asked the same question, but this time with a different system of equation. So use Gauss method to decide on the type of solution of the solution of the following system. And in this tutorial, I will go a little bit faster than the previous tutorial, okay? This is our second time of doing Gauss's method, so hopefully you are getting good at Gauss's method. So our new system is x plus y plus z equals to 2 minus x plus y minus z equals to minus 2, and x plus 3y plus 2z equals to 3. So we are asked to perform Gauss's method. Okay. So here as well, I won't go that fast, but a little bit faster than previously. And here I'm going to do the operations, okay, as well. Again, sorry. So what I am going to do, let me rewrite my linear system. X plus y plus z equals to 2 minus x plus y minus z equals to minus 2, and x plus 3y plus 2z equals to 3. So we are going to perform Gauss's operations or Gaussian operations. So as you have seen previously, what we have to do, we pick the first row. Its leading term is x, and we are going to use that x to eliminate the x's in the rows below the first row. So in order to be able to cancel minus x here, I'm just going to have x plus minus x. Okay, we are just going to add the two rows. And adding the two rows, okay, will help us to cancel the x. So let me continue the operations here, okay, for clarity purposes. Row 1 is x plus y plus z equals to 2. And we say row 2 is minus x plus y minus z equals to minus 2. So x minus x is 0. We are left with 2y. Z minus z is also 0. Okay. So we are left with y, 2y equals to 0. This is going to be our new row 2. We are going to change row 2 with, with this new equation. So what operation we have done is row 1 plus row 2, okay, will give us, in this question I won't change colors too much, as the previous question was our first time of doing Gauss's method, so I took plenty of time. If you think that this question is a bit faster, maybe go and look at our previous video, okay, the previous question in this tutorial. Okay, it was a bit longer. Okay. So row 2, our new row 2 is 2y equals to 0. Okay, so that was our first operation here. Now I'm going to use row 1 to eliminate the x in row 2, in row 3, sorry. So what do I have to do to row 1? Okay, is to multiply row 1 with minus 1. Okay, so my second operation is here, minus row 1, okay, which is minus x plus, minus x minus y. I'm going to multiply the entire row by minus 1. So minus x minus y minus z equals to minus 2. And row 3, I don't do anything to it. I hope you are getting the process. If I want to eliminate the x in row 2, for example, I use the x in row 1 and I do the multiplication to row 1. We actually don't do anything to row 2. Okay, I do the multiplication to row 1 to be able to cancel the x in row 2, and then I replace the row 2 with the new equation I get by combining the two rows. Is that okay? Once you understand, these these little subtle ways, I think you are going to find Gauss's method very easy. Okay, if this is your first time, it can look a bit complicated, but believe me, it's very simple. So we are here doing our second operation, which is to eliminate the x in row 3. So we just recopy row 3 here, x plus 3y plus 2z equals to 3. Okay, so we have 2y plus z equals to 1. This is going to be our new row 3. Okay, so come here, what have I done is minus row 1 plus row 3. Okay, is 2y plus z equals to 1. Now we have finished eliminating the x's in the rows below row 1. Now we are going to use the y in row 2 to eliminate the y in row 3. Is that okay? So this is going to be our third operation. Here is so I'm going to use row 2. How do I cancel the 2y in row 3 is to multiply row 2 by minus 1. So minus row 2 equals to minus 2y equals to 0, and row 3, okay, is 2y plus z equals to 1, and the answer is going to be z equals to 1. This is going to be my new row 3. Is that okay? So let me write it here. So we have a row minus row 2 plus row 3 is equal to, we have x plus y plus z equals to 2. We haven't done anything to row 2, row 1. Okay, in the previous system, we have 2y equals to 0. And now in this new system, we are going to write z equals to 1. As you can see, we have our echelon form. Is that okay? And now let's decide on the type of solution set. In the lecture, we said if we arrive at the echelon form and we have no contradictory equation, do we have a contradictory equation in the echelon form? No, we have z equals to 1, 2y equals to z. Okay, we don't have minus 1 equals to 5. No, we have no contradiction. So we have arrived at echelon form. We have no contradictory equation. Okay, and also we have a row where each variable is leading. We have 3 variables in total, right? In row 1, we have x leading. Okay, those three variables are x, y, and z. In row 1, we have x leading. In row 2, we have y leading. And in row 3, we have z leading. So we have a row where each variable is leading. Therefore, okay, so we have, let me write it down. We have each variable, each variable is a leading variable, is a leading variable in its row. Therefore, what do we have? That means we have a unique solution. Is that okay? So our original system has a unique solution. At the moment, we are not going to write down that solution yet, okay? We are just going to decide on the type of solution. Okay, so this is going to be the end of this tutorial. As I said, it's a bit shorter than the previous one. And in the next tutorial, as you can guess, we will do a question where we will have this time infinitely many solutions. Is that okay? See you in the next video.